Now that you've been introduced to the three different types of nuclear radiation, it's worthwhile taking a couple of minutes to compare and contrast them. So let's start by considering the mass of the particle that's released. Now, in an alpha decay, a helium nucleus is released. So this has quite a large mass when compared to the mass of an electron, which is what we get released during beta decay. Or if we're considering beta positive decay, then a positron is released with the same mass as the electron. So the mass of the particle released in alpha decay is much larger than the mass of the particle released in beta decay. And then in gamma decay, we have electromagnetic radiation released, which has absolutely no mass. So there's no mass involved in that case. With charges, for an alpha particle, it has a charge of positive and 2 times the charge on an electron. For a beta decay, it's 1 times the charge on an electron, and then a gamma particle is completely uncharged. So the mass that we've just looked at actually relates to the next property, the speed that the particles have when they're released from the nucleus. So as the particles are released from the nucleus, momentum is conserved. Now, for alpha decay, because the alpha particle has a lot more mass than in beta decay, this means that it travels a lot more slowly than the beta particle does. So alpha particles travel relatively slowly when they're released from the nucleus. Beta particles have medium speed, and then we know that gamma rays are electromagnetic radiation, so they travel at the speed of light. So they're the fastest possible radiation. Now it's also worthwhile considering ionizing ability. So ionizing ability relates to how easily can these particles, once they're released, knock electrons off other atoms and so ionize them. So helium nuclei, being quite heavy and having quite a lot of charge, are actually very good at ionizing other atoms. So if you hit a helium nuclei into another atom, there's a relatively high chance that it will become ionized. So the alpha particles have a high ionizing ability. If you shoot an electron at an atom, there's a bit of a lower chance that that atom will become ionized. So the ionizing ability of beta radiation is medium, and of gamma radiation, because this is just electromagnetic radiation, it's got a low ionizing ability. Now, penetrating power. This relates to how far into a substance the radiation can travel. So while alpha particles are very good at knocking electrons out of things, this in terms means that they are relatively easy to stop. And so the penetrating power of alpha radiation is actually fairly low. They get stopped relatively easily. Whereas beta radiation, this is medium, and gamma radiation, this is quite high. So related to that is, well, what can we use to stop this radiation if we wanted to? With alpha radiation, it can actually be stopped with generally just a sheet of paper. To stop beta radiation, we need a few millimeters of aluminium. So 1 sheet of aluminium foil won't do it, but a few sheets would do it. And with gamma radiation, we need a few centimeters of lead in order to stop that gamma radiation penetrating. Very soon we'll be looking at applications of radioactive decay. So the applications are very much related to the properties of the radiation involved. So these properties that we've just looked at will tell us which type of radiation it's useful to use in which circumstance.